So hello dear students. Today we will study about Lewis equations, a very important topic in condensed matter physics for exams. So these are the equations to study the details of a crystal structure. These are the extension of Bragg's law of diffraction. So here are the two parallel planes in a crystal structure, and suppose these are the two atoms from which reflection of X-rays are taking place. X-rays falling on atoms, incident X-rays are like these are the two incident X-rays shown here, and their direction is represented with n naught cap unit vector. Parallel beam of X-rays falling on atom A and B lying on the parallel crystal planes at an angle theta, and these two rays are reflected according to laws of reflection, and the outgoing directions are represented with a unit vector n cap. So this is an incident beam, this is a scattered beam, reflected beam, or you can say diffracted rays. So n naught cap and n cap represents the incident and scattered beam directions for the two crystal planes or for the atoms A and B. And if we join the scattering centers like this, and we mark this as R vector. R vector is the vector joining the two scattering centers. We draw perpendiculars here, one perpendicular here. Let this is point C. One perpendicular here. Let this point is D. One perpendicular is drawn on the incident X-ray, another perpendicular is drawn on the scattered or reflected X-ray. The path difference between the two scattered rays from A and B are given by path difference. It is given by AD minus BC. So AD is in the direction of n naught. So we can write it as R vector dot n naught cap. BC is in the direction of n cap. This is also the n cap direction because both the scattered rays are parallel. So R dot n cap. So we take r dot common. It is n naught cap minus n cap, and we mark this as by equation number 1. So if we put n naught cap minus n cap, it is equal to capital N cap. Then path difference will be r vector dot capital N cap. Or we can also mark this as n vector. So this is number 2. So if we look at the directions, this is the dotted ray is the incident direction. As the scattered or diffracted rays follow laws of reflection, then this angle will be theta. This angle is also theta, as this angle and this angle are vertically opposite angles. So the angle between the n naught cap direction which is the dotted ray and n cap direction, it is 2 theta. So magnitude of n vector can be obtained by using simple parallelogram law for 2 unit vectors, which is magnitude of n cap naught square magnitude of n cap square minus 2 magnitude of n naught cap n cap cos 2 theta. So as it is a unit vector, so its magnitude will be 1 cos 2 theta. So it will be 2 minus 2 cos of 2 theta. 2 theta is the angle. So it will be 2 1 minus cos 2 theta. So very simple trigonometric relation. So 1 minus cos 2 theta is 2 sin square theta. So it will be 2 sin theta. So we mark this as equation number 3. So now we have path difference between the two scattered radiations, and if we are to study the diffraction pattern, then we are to convert this path difference given by equation number 2 into phase difference. So the phase difference between the scattered X-rays from A and B is given by, it is a general formula 2 pi by lambda into path difference. So phase difference will come out to be 2 pi by lambda r vector dot n vector. So we mark this as equation number 4. And in the diffraction pattern, we will get a maxima in the diffraction pattern. We will get a maxima if and only if phase difference is, you might have studied in lower classes the diffraction pattern. Maxima will be obtained when phase difference is integral multiple of 2 pi. Then the crest falls on crest, trough falls on trough, and we will get a maxima. And if we suppose r vector coincides with any of the crystallographic axes, then what we will get? We will get for if r vector coincides the x-axis, then we represent the phase difference as phi a, and we will change r vector with a vector, and it will be integral multiple of 2 pi. Here we write h dash. Similarly, if it coincides with y-axis, then we replace it with b vector. It will be 2 pi into k dash. And it will be coinciding with the z-axis or third crystallographic axis, then it will be 2 pi into l dash. And for a plane, HKL plane, if we write h dash is equal to nh, k dash is equal to nk, l dash is equal to nl, that is n is common factor, then the above equations, they can be modified as phi a, it will be 2 pi by lambda a vector dot n vector, it is equal to 2 pi nh, phi b, it is equal to 2 pi by lambda b dot n, 2 pi nk, phi c, it will be 2 pi by lambda c dot n, 2 pi nl. So simplifying the equations, so first equation 2 pi cancels, so it gave us a dot n, it is n h lambda, b dot n, it gives n k lambda, c dot n, it gives n l lambda. So we are having these three equations. If n vector makes an angle of alpha, beta and gamma with the three crystallographic axes, a vector, b vector and c vector, then a dot n, it will be written as an cos alpha nh lambda, bn cos beta nk lambda, cn cos gamma nl lambda. And from the equation number 3, n, it is equal to 2 sin theta. If we substitute here, so it will be 2a sin theta cos alpha, it is equal to nh lambda, 2b sin theta cos beta nk lambda, 2c sin theta cos gamma nl lambda. So these are the Lewis equations used for study of crystal structure in detail. Next part is derivation of Bragg's law of diffraction from Lewis equations. So as we have considered a family of parallel planes, so consider a plane having Miller indices HKL. Then it will be having intercepts of A by H, B by K, C by L respectively along the three crystallographic axes. The details about the intercepts we have studied in many of the previous lectures. So if we represent the three crystallographic axes like X, Y and Z and say this is the origin, then the 3 points, this intercept, it will be A by H, this point it will be B by K, this point it will be L, C by L. So these are the three intercepts. And we join the three. So this is the crystal plane having Miller indices HKL, and we draw a perpendicular on this crystal plane like this at point N, and D is the length of this perpendicular, and this plane it makes an angle of alpha with x-axis, beta with y-axis, gamma with z-axis respectively. So clear from triangle, this point is A, from triangle ONA. So if we write cos alpha, it will be base upon hypotenuse. So it will be ON upon OA. As this is the 90-degree angle, it is a perpendicular drawn on the plane. This is a 3D diagram. So it is D divided by A by H. So cos alpha, it is equal to DH divided by A. Similarly, you can also write A cos alpha, it is equal to DH. Similarly, B cos beta, it is equal to DK. C cos gamma, it is equal to DL. So if we will be using this in Lewis equations, if we represent this by equation number, I think 5. So equation number 5 of the previous article and equation number 1. So substituting this in Lewis equations, so it will be 2 sin theta into dH is equal to NH lambda. Similarly, 2 sin theta, it is equal to dk nk lambda. Similarly, 2 sin theta into dl, it is equal to nl lambda. So if we cancel the terms, and from all the three equations, they will lead to 2d sin theta, it is equal to n lambda, and this is nothing but Bragg's law, and this Bragg's law has been derived from the Lewis equations. So dear students, this is all for today. Keep in touch for next lectures. Thanks a lot.